you use the nuclear bullet, it strikes the uranium, it splits up into big chunks like barium and krypton, but remember in our band of stability, the bigger you get, the more neutrons you need to keep it stable. So when we get down into smaller stuff, we need fewer neutrons. And in fact, we have to have fewer neutrons to have a stable form. So the only way we can have stable barium and stable krypton is if we're also getting rid of some extra neutrons. Okay? So when we do all that, we get all this different stuff so that we got stable barium and krypton. And then those neutrons then go on to become nuclear bullets, knock another uranium into. Now, if we control those neutrons, if we take our samples of uranium and put them in a heavy casing of some kind like lead, and then only let enough of it be exposed so that we can kind of keep it under control so the reaction doesn't get away from us, we can produce a lot of heat in a nuclear reactor and we get steam which produces electricity. Okay? On the other hand, if we don't have it controlled, then the reaction gets out of control and we get a nuclear explosion. Or at least a nuclear meltdown. Okay?
So what's the difference?
An explosion and a meltdown?
Right.
There's a famous movie called The China Syndrome. And a meltdown means that the core just becomes so hot you can't keep it in the containment building anymore and it sinks down. Supposedly, the China Syndrome because it sinks all the way to China, but that's not really what happens, okay? But it just basically, it burns its way right through the crust of the earth. That's supposedly what happened. Now, you know, we had that problem with that reactor in Japan after the tsunami when the coolant, they couldn't get the coolant in there anymore, and so that basically was a meltdown. We had that happen at 3 Mile Island, essentially, in the United States. Had that happen with a much more serious result in Chernobyl, Russia. So, I mean, it's happened. So,
It melts all the way through the crust.
no, it melts. It doesn't really melt all the way to the crust. It melts down until enough of the heat is absorbed that it stops melting its way through again. Okay, eventually you get enough heat absorption that it never really. I don't know that it ever really gets to the into the molten part of the crust. So now fission then means we take a couple of really small elements. Okay, now when we talk about fusion. When we talk about fusion, most of the time we're talking about what's the kind of thing that's happening in the sun. Typically with the sun in the sun, we are talking about several different reactions that take place. The most common one we speak of are tritium and deuterium that come together. That's a 3 and a 2 mass. Tritium is 3, a mass of 3 hydrogen. And deuterium is a 2, mass of 2. Okay? They come together and they form a sort of a temporary form. And it's really unstable, and that's where we get all that energy from. Okay? Well, this then decays into a couple of stable forms. We get helium, okay, but we also get an extra neutron over here. No, this is the reaction. This is the temporary form, the unstable activated complex. Okay? And so all the energy comes out of this activated complex and it goes through this decay, spits out a neutron, and that's where we get all this energy. It starts out as gamma radiation near the core of the sun, and it goes through these different cycles through the different layers of the sun, and when it comes out the outside, we got some visible light and some infrared light that keeps our planet alive, or the plant life and animal life alive.